This is the positive terminal of the battery, and the negative terminal is over here. The battery is shaped like an S. So it goes this direction across this bus bar, back this way, across this bus bar, up that way, the third bus bar, and finally to the positive. After that, each positive and negative goes through its own fuse, so that if either the positive or the negative is shorted to any part of the battery, the fuse will blow at the negative or positive terminal. The power wires come out this direction. We're using two 14 gauge THHN stranded copper wires to carry the current, which is supposed to be around 15 amps. This switch right here is designed for 277 volts AC, and that results in a peak voltage of around 392 volts DC. The switch is not designed to operate under load, although in an emergency, of course, it can be used that way, and therefore we're not really looking for the DC current rating of the switch, but rather we'll just use the AC voltage just to make sure that the dielectric will hold up. In addition to that, I do have the switch wired in a series configuration where power enters through this left lead, exits through this one over here, goes through this little loop, back to the opposite side of the double pole switch, and exits. This ensures that even if one of the two sides of the switch is bridged, the switch will still open circuit in the event of some kind of catastrophe. From there, this being the negative lead, we have an Anderson power pole, which are rated for 600 volts DC and up to 45 amps, these particular ones are. They're also soldered. This is one of the 45 amp contacts, and I've got two 14 gauge wires crimped into there and then soldered. This one that I'm holding will be the positive lead, and that should complete the electrics of our battery.